Hello, my name is Ron Dorn, and it's December of 2022, and I would like to update the global warming and ozone lectures for the GPH 111 class. The existing lectures that I have already done, and the first versions that you watch, I think are very good at laying out the basic science of how global warming relates to the global radiation balance and how the ozone issues relate to the global radiation balance. But there's so much happening in science and in the media and in the public at large on both issues that I like to update the material and provide you my perspective on the science end of what's going on. So I'd like to share the screen and then make this brief presentation to you. The idea is that most of the questions that you'll see on the quizzes will come from the base lecture because that provides the basic science, but there will also be a few questions coming from this presentation. The idea here is that things have come out throughout 2022 and will come out in 2023 about ozone. For example, new studies have linked wildfire in the troposphere to ozone depletion in the stratosphere. And the idea is it's going to, as wildfires become larger and more frequent, they might stall ozone recovery. And then there's always issues in the news on how specific meteorological events, like big flooding in West Africa that killed 800 people, there are claims that it's 80% more likely that this happened because of climatic change. So if you look at recent polling across the US, 24% of those who have been personally affected by extreme weather events in this 2022 year, and also in the past 5 years, say that extreme weather caused serious health problems for their household. And then a poll in July of 2022 gives you the geographic perspective on Americans that think Congress should do more to address global warming, and also who Americans think will be harmed by global warming, themselves, others in the US, their family. So it's an interesting issue of how people perceive things, but the purpose of this science presentation is dealing with how the global radiation balance works in relationship to these issues. I'll first cover some updates to global warming and then updates on the ozone issue. I'd like to remind you of what is climate change. There is a trend, and that's climate change. And then there's a cycle. And then there's also randomness. A lot of meteorological events are driven and are considered somewhat random, and they're very difficult to connect with either cycles or trends. So what's happening with the climate change debate is you get all three things going on: natural cycles, a change or a trend, and randomness, and trying to sort these things out on how the CO2 and other greenhouse gases in the atmosphere change the radiation balance of the Earth that then changes the cycles and trends as opposed to random meteorological events. Is very complicated. But I'd like to remind you that pretty much everybody agrees. The few skeptics that are left and people who are religiously predisposed to believe that global warming is all anthropogenically driven are up. There's no question that everybody agrees that greenhouse gases are way up and it's anthropogenically caused. There's also very little debate that more carbon dioxide in the atmosphere is greening up the planet. And that is including making yields, for example, in northern Germany, where the lower left-hand chart comes from, yields of winter wheat, rye, early maize, barley, sunflower, spring wheat, yields go up because the plants get more carbon dioxide and they're more productive. And there's also a little debate that a lot of changes are happening to the Earth, like in the permafrost, where there's a lot of methane that's stored in the permafrost that's being released as things melt. There's also little debate going on that the nights are getting warmer. And this is probably due to not only things like the urban heat island, desertification, but also greater CO2 in the atmosphere. And that warmer nights tends to be associated with parasites and vectors that thrive when you don't get as cold. And a recent analysis in August of 22 indicates that about half of pathogenic diseases could potentially be aggravated by global warming and climate change. Another factor that pretty much everybody agrees on is that because there's more CO2 in the atmosphere, that increases ocean acidification. And when the ocean is more acid, it makes it more difficult for coral and people who makes calcium carbonate in their shells, fishes, to actually make these structures. Because with more acidity, there tends to be a decline or dissolution of calcium carbonate structures instead of a production, or at least stabilization. So the acidification is a very big issue in the oceans. And there's very little disagreement that the media has tended to produce story after story after story. If you're in the media yourself, you know this as a story having legs. For example, at the end of 2022, there was a big international COP27, a political issue where little was done, a little bit of money being thrown at some lesser developed countries. And there's always things in the news, especially in California and the LA Times. And this story here is from November. Climate change is rapidly accelerating in California, a state report says. And you get news that weak tropical cyclones, which are hurricanes, are intensifying into bigger ones because of warmer ocean surfaces. And you also get studies saying, hey, no worries about it. Even if it warms, people can handle it. So you get a lot of stories floating around the news. Connecting it to the science is what my job is, at least in a 100 level context. In the last year or so, there's been science about that anthropogenic warming is leading to the emergent mega drought in Western North America that's drying up the Colorado River basins, that's causing big droughts in California and in the Southwest, spreading up into the Middle Rocky Mountains, causing reduction in the amount of river water to the Colorado drainage system. And Australia is dealing with a lot of issue of drought and then floods and then drought and floods. And so there is an ongoing trickle of articles trying to connect these very specific events to global warming of the planet. There's also a trend in articles about dams altering the climate, that because we're storing a lot of water, there are a whole series of issues associated with hydroelectric power and dams. And one of them deals with the amount of water supply that global damming, for example, may have contributed to declines in groundwater, in water supply in rivers, and actually may be influencing the global radiation balance because the surface water of the dams influences the albedo. So if you have surrounding glaciers or snow and you have a dam, you're going to absorb more sunlight, and that might result in more snowmelt. So people are beginning to deal with more issues related to global climate change than just increased greenhouse gases. And in the last year, there's been a trend towards, say, going from no, sea level rise before 2050 isn't going to be that big of a deal. That's what I presented in the original lecture. However, there's been a new series of studies by unbiased organizations in the US government, the US Geological Survey, the National Oceanic and Atmospheric Administration, and NASA, indicating that with a lot of events happening, it's likely that the coastal areas around the US could see up to a foot of sea level increase by 2050. So that's on average. So you increase sea level a foot and you drive things like storm surges even more, and high water, high tides even more. So just hang on and we'll see how this plays out. There's also a concern with sea level rise about the ice caps, the Antarctic ice caps and the Greenland ice caps, and especially the shelves around the ice caps. So there's an ongoing debate about whether more warmth in the atmosphere will produce more evaporation, which will produce actually more snow for the center of Antarctica and Greenland. And then hopefully that growth of snow in the center, which is normally quite small, might pick up to the point where it can counteract the release of sea ice, the melting of sea ice, and the release of icebergs. It's pretty evident that a lot of shelves are ready to collapse and enter the oceans and melt, but it's not very clear on whether the greater moisture in the atmosphere can counteract this. One event is sudden, the other event is slow. In the last year or so, the international governmental organization that assesses climate change has tended to turn towards regional rather than global issues. And I personally like this a lot because no matter whether you believe that climate is changing because of humans, there's no question that climate always changes. And there is always regional differentiation of the effects. And so I think it's very important that all the stakeholders at the county level, the state level, and international level deal with changes in their region, whether it's more rain or less rain, whether it's desertification or whether it's urban heat island, to understand the regional changes regardless of the cause and come up with plans to ameliorate the effects for people. There is a big elephant in the room of the global climate system, and that's what's called the thermohaline circulation that I explained in the ocean general circulation lecture. The idea is that there's a lot of cold water that sinks in the North Atlantic and then emerges elsewhere and then warms like the Gulf Stream along the east coast of the United States. This conveyor belt transfers a huge amount of heat, and there's ongoing research where people studying this think that it's slowing, and if you slow this heat transfer, it'll have a big effect on climate. Exactly what effect on climate is not certain. And then there's always research on understanding the processes that can cause the sudden collapse of this Atlantic circulation system. And the sudden collapse of the system would dramatically alter climate. You'd get snowstorms, probably not another ice age, but you get a heck of a lot worse winters, say in Northern Europe, and there would be drastic effects on the climate of North America. So this is being monitored, and a lot of research has been done in 2022, nothing conclusive. The broader perspective that I'd like to reiterate is that we've had a lot of variations in temperature over the last 60, 100 million years, that we reached a low point in carbon dioxide during the last ice ages, that periodically during the Eocene and the Pliocene, and then in the time of the dinosaurs in the Cretaceous, there were much higher levels of carbon dioxide, much higher levels of methane. And it's only been since the Industrial Revolution that we've begun to approach what's called the Pliocene levels, when the Arctic was last ice-free. So I always like to come back to these sorts of graphics that you could pause and examine, that the Earth has had these changes in the past, and it's going to be very important to study what these past conditions are like to be able to understand what might happen in the future. Of course, periodically, several times a month, there pops up an idea that we can engineer a solution. In March of 21, the National Academy of Sciences had a series of recommendations for how to do solar geoengineering. And there's three broad contexts to engineer a solution. There's the social dimensions, there's the textual dimensions, and then there's understanding the ability to pull things back. Is it permanent, or is it something we can manipulate? But the whole idea is that when you start messing around with the stratosphere by increasing the scattering of incoming solar radiation by having particles up there, or you change what's going on in the troposphere, or you try and make marine clouds more brighter to reflect more sunlight, no matter how you plan to engineer things, because there are always engineers that want to do this, I guess my question is, how would you pull things back? How would you be able to run an experiment to find out its effectiveness and whether or not you can turn off the switch? Now let's turn to the ozone. In October 22, in November of 22, there was a lot of media coverage about how the Antarctic ozone hole is better and things are recovering. So you get stories like scientists predict the hole in the ozone layer will close in the next 15 years. And then you get NOAA saying, well, hold on here. It's slightly smaller, but things get bigger and smaller and bigger and smaller. And then there's ozone destruction of the North Pole, which results from extreme winters because you get the polar stratospheric clouds forming over the Northern Hemisphere. And then you get a realization that maybe the Antarctic ozone hole being studied smaller in 2022 wasn't quite right. Maybe it's a little bit bigger for the third year in a row, but things are trending better. So there was a lot of mixed coverage with most people saying, oh, we've saved the planet, and other people saying, oh, hold on, it's not very clear. I still come back to the point that there are a lot of ozone-destroying chemicals being produced, like chlorofluorocarbon 11 emissions in China, that are being monitored, that it's released, not released, released, not released, that there's always new threats found that could destroy the ozone layer. And these form complications and have to be dealt with. For example, there's research indicating that wildfire smoke could set things back. There are always new chemicals that are being emitted, like HCFC 141b, that's still being produced illicitly and also being released from appliances that are decaying. And then there are always studies about there's strange things being detected, like a new compound, hydrochlorofluorocarbon HCFC 132b, which was never detected prior to around 2021, that's popping up. So the moral of the story for me is that it's a mixed bag. The Arctic ozone hole keeps growing. It did in 2022, and then it gets better. It's an issue depending upon how cold it is in the Arctic. And hopefully the Antarctic ozone hole is somewhere near in equilibrium where it can slowly get better if we can get these illicit chemicals out of the air. But I'm not breathing a sigh of relief because the ozone issue worries me tremendously. In the end, I come back to this comic. You get a professor on the pulpit or a sage on the stage talking about all these liberal agenda items: energy independence, preserving the rainforests, having a sustainable environment, green jobs, livable cities, renewables, clean water, healthy children. All these things that hopefully should not just be a liberal agenda. These things should be something that we all want. And so my perspective is, why are we arguing about this politically? These are all very good things. And the bigger picture is, if global warming is purely a liberal agenda item and conservatives don't want to follow it just because liberals are pushing it, what if it is a big hoax and you reduce carbon dioxide and other greenhouse gases and do all these things? You're still creating a better world for us in the future. So no matter where you sit on this issue, politically or scientifically, why not work towards these things and take a conservative perspective that by reducing greenhouse gases, it's probably good for all of us in a whole variety of endeavors. Feel free to contact me with your views. We can have discussions over the science of it. And you're welcome to contact me if you think I'm too much of a liberal professor. I would greatly love to engage, but first and foremost, on the science of the issues. I hope you appreciated this update. Thank you for your patience.